Hi, Al here again with another video tutorial about the Mr. Machinist computer program. And what's this? This is Mr. Machinist for DOS. This is an old DOS program. Mr. Machinist used to be in DOS when it was first put out. In fact, I started it in late 80s, and I even ran BBSs and things like that. But all that to say that there is still the Mr. Machinist DOS version that I had that I would give to people who registered Mr. Machinist. And this is it right here. This is it has a lot to it. File menu. You hold down the Alt key, hit F for the file menu, and you can see there's all kinds of stuff in this thing. In fact, I probably put too much in here. It's doing stuff now that us as machinists, with the technology we have these days, we don't need anymore, because they're on our machines and they're on our calculators. Anyway, this can even make G-code for both circles and sequence and unsequenced CNC G-code files, split a G-code file, and your average edit programs and save, some DOS shells, things we don't do anymore. The manual edit, the really relevant things though are over here with the starting at the circle, the math, and the threads, compound rest travel. The areas and volumes are a really good one. All these areas and volumes are not in the latest Mr. Machinist for Windows. In fact, they're only in this old DOS version. While I'm on A through H as opposed to I through R, S through Z. In example, I through R, hit the Enter key, and here they are. Let's say prism, and there's you input the area and the height for the prism. Area 2.3, height, I don't know, 1.2. Let's try and hit the volume is 2.76. And let's say, as an example, this area and volume over here, A through H, the area. How about ellipse? Let's go to the ellipse, hit the Enter key. The major axis dimension and the minor axis dimension. What in the world are they? So let's strike the F1 key. Area and perimeter of an ellipse. This function will ask you for the major axis dimension and the minor axis dimension, and then give you the area and the circumference of the ellipse. Well, it might seem simple to some people, it might not. Major axis, minor axis. Get rid of the help file there. Well, major's bigger, minor's smaller maybe? Let's try that. 2.3. Excuse me. Minor. 1.2. Okay. Hey, we got an answer. There's the area, there's the circumference. As you can tell, I don't know everything about what's happening here. I know the formulas and these numbers are correct, and but I haven't worked with a lot of these things in the field. And there's your areas and volumes anyway. You have rates over here. Speed and feet for drilling, speed and feet for milling, speed and feet for tapping. Let's try tapping. Let's see what that does. Tap size. Well, what do I put in there? Well, let's hit the F1 key. See if it tells us. Okay, this menu function in Mr. Machinist will give you the speed and feet of a tap used in a CNC machine that utilizes rigid tapping. Okay, blah blah. Let's go on and see if we can find something there. Available tap sizes. Okay, this is how we would input the tap sizes. These are some general speeds and feeds for tapping. Okay, let's do that quarter 20, as we see right over here. We'll try that. I'll hit the escape key to get rid of the help file, and we'll input quarter -20. See if that works. And there it is. If we're doing machine steel, it'd be 560 RPM at 28 inches a minute. If we're doing aluminum, it'd be 1,240 at 62. And as you can see, that's a generalization. And let's get rid of everything here. Go back to rates. We'll try like drilling. Material. What does it mean? Hit the F1 key if you don't know. Material list. This is a list of materials. Blah blah. Let's see what the list of materials is. Just like the things you would see in the Mr. Machinist. I'm sorry. Just like the things you would see in the Machinist handbook. Oh. How about 1018? That's a pretty common material. I'll hit the escape key and we'll put materials 1018. Drill size, quarter-inch drill, 0.750. And we'll say OK. And we get this. This is pretty cool. I remember programming this. Mr. Machinist for DOS took, I'll tell you what, it took, I don't know, many months, years I kept at it. A lot of my life went into this, and anyways, you might not think so by seeing it. This is the inches per revolution. If your material is 1018 and you're drilling at 750, that's your inches per revolution minimum and maximum, and inches per minute minimum and maximum. These are generalizations according to the Burnell and the Rockwell hardnesses. As you can see, if we have a harder material, we click harder and it changes everything to a little bit slower RPM, 458 RPM. For something Burnell at 125 to 175 or Rockwell at 0 to 6. We'll say it's even harder, and that RPM right there, 458, ought to change. We'll say harder. Now it's 357. You can print it. You can see details here. Let's see what that does. Okay, it made a text file of all the things that we're asking here. And if I remember correctly, yeah, every time you chose something, it input it here. You could print this out to your printer. Anyway, there's a lot to it. I just wanted to go over to you with you some of these things: threads, compound rest travel, where you input the threads per inch and the angle of the cut. And let's see if the help file says anything about what I need to do here. Compound rest travel, yeah, it explains to you what you need to input. Some facts about threads. Let's get out of there. Let's get out of there. Alt T will bring down threads. Okay, there's M. There's Trig, and here's the Trig. There's your little right triangle, and you input two knowns like, okay, side A is 1.234, and then we'll go down to angle A. Let's say angle A is 23.456. We'll hit the enter key until it gets the OK button, and boom, there's your stuff. Inner circle, outer circle, perimeter, perpendicular line, and you can see there's your answers. I'll hit the escape key to get rid of that. Hold down the Alt and hit C. I'll hold down the Alt and hit M to bring back the math menu. You got your oblique triangle, conversions, polar coordinates, distance across square corners, distance across hex corners, between 2 points, middle of 2 points, 3 points shifted and rotated. This is a neat function where you input 3 points, new X and Y origins, degrees of rotation, and you'll get your new information. Anyways, you have a lot of different functions here. Circumference area, 3 points on the circle, pin in a diamond. Your bolt circle here. Bolt circle diameter 12.3. Number of holes 24 holes. Angle of the first hole is say 0 degrees. Hit OK. It made a text file that you can print to your printer, and there's all your information right there with all your X and Y coordinates. Okay, your 24 holes. Anyways, this is it. That's Mr. Machinist for DOS. Still available, basically. Now, one thing I do want to mention, the contact information, the website stuff in there, where I used to live back in '94, where this particular version of DOS was still going on, is not relevant anymore, of course. I've moved from those places. Those domains and sites are wrong and incorrect, and phone numbers are not correct. In fact, it even has my BBS information, which I used to run a BBS a while ago supporting Mr. Machinist. And anyways, if you like the DOS program, that will come with Mr. Machinist, and it's very powerful. It doesn't show you a lot of graphics and things like that, but as Machinist, we deal with numbers. We want numbers to take back to our machine. We want to input quick our numbers. We want the numbers given to us quick, so we can just get going and make chips. Anyway, keep making chips, and this is Al with another video tutorial about Mr. Machinist software. Thanks for your time.